Scientists have found an invisible star at the Milky Way center, a star that helped our galaxy be born. 26,000 light-years away, in the galactic center, a massive, invisible object started spreading everywhere, and you don't even know that you're breathing it right now. It all started in the 70s, when an astronomer named Vera Rubin was studying the Andromeda Galaxy. She decided to check whether stars move in a predictable way. Now let's say you're spinning a ball on a string around yourself. The closer the ball is to you, the faster it moves in a tight circle. But if you let the string out longer, the ball moves more slowly in a bigger loop. That's how gravity works. And the same goes for planets. The closer ones, like Mercury, zoom around quickly, completing their orbits in months. The far ones, like Neptune and Saturn, take their time, decades, to make one rotation. The stars themselves should orbit the centers of their galaxies the same way. The closer ones move fast, the farther ones are slower, right? But when Vera measured the speeds, she saw something impossible. They weren't slowing down. The faraway stars were moving just as fast as the ones near the center. By all logic, the galaxies should have torn themselves apart, but they didn't. And that meant something was holding them together, something undetectable. Some massive, invisible object in the galactic center warping reality without ever revealing itself. So she checked over and over with different galaxies. This wasn't a fluke, it was happening everywhere. Rubin had accidentally uncovered proof that galaxies were drowning in something far heavier than all the stars, planets, and gas in our entire universe combined. It was holding us with ghostly hands. Astronomers called it dark matter because it doesn't glow, doesn't reflect light, doesn't seem to interact with anything at all. It's just there. But all the calculations show us that it exists, and not merely exists, but makes up 85% of all the mass in the universe. We know that it sculpted galaxies. Without it, the world as we know it wouldn't exist. And yet, just like with an invisible star scientists found at the Milky Way center, the only way to detect it was through gravity. So how do you find something that refuses to be found? Recently, scientists discovered there might be an invisible star at the Milky Way center, and this fascinating discovery might finally help us understand what dark matter looks like. They began looking for dark matter's fingerprints, any signs of its presence anywhere. They studied how galaxies moved and smashed particles together in giant machines, hoping to create tiny bits of dark matter in the lab. This didn't really lead to anything. They didn't even know what to look for. Is dark matter even made of particles? There was a theory that suggested that it's made of ghostly particles that barely touch anything, or even weirder ones that might flicker in and out of existence in the blink of an eye. There was a problem, though. If dark matter really worked like that, then the centers of galaxies should be packed tight. Tons of matter would be crammed into a tiny space. But in our universe, galactic cores seem strangely soft, spread out, almost gentle. A new theory emerged, and it was wild. What if the dark matter at the heart of galaxies isn't made of heavy particles at all? What if it's made of something so delicate that it behaves more like a strand of hair? These hairs could be made of something incredibly light, lighter than anything we've ever seen, and billions of times smaller than a neutrino, which is already the lightest known particle. They called this idea fuzzy dark matter, and it might change everything we thought we knew about the universe. A team of astrophysicists wanted to test this idea, so they ran a simulation, creating a simple model of a galaxy with two main ingredients: a whole lot of fuzzy dark matter and a little bit of gas, the same kind of gas that forms the stars we can see. They pressed start and just let the system evolve by itself, watching how the two would interact. At first everything was pure chaos, but then the fuzzy dark matter started to gather. It pulled itself together, forming a massive invisible object near a galactic center. The gas followed, spreading throughout this ghostly mass, mixing with it and glowing faintly. And then it suddenly formed something incredible: dark stars. Not typical stars like our sun, blazing with heat and light. Instead, It's enormous, massive, invisible objects, a hybrid of two different kinds of matter. We've never seen anything like this before. An object that would stretch across thousands of light years, and yet they'd be almost weightless, more like cosmic puffy clouds than anything else. Scientists called them Fermion boson stars. Finally, this dark matter thing is starting to make sense. The core of this strange invisible star would have just the right density, not too dense, not too loose, and it looked exactly like what astronomers actually see in real galaxies. If it's confirmed, then it would finally explain how dark matter behaves and works. And if they're right, then every galaxy in the universe could be tied to one of those vast unseen giants. The Milky Way hidden star might be one of them, shaping our galaxy in ways we never realized. What's wild is that this stuff wouldn't behave like normal matter. It wouldn't form anything solid. Instead, it would be more like a complex, ever-moving web of filaments or hairs. This also means that Earth might be completely surrounded by it. Dark matter still follows the rules of gravity. As it moves past planets and stars, gravity pulls it into focused streams, so it's both hugging and passing through our planet, wobbling consistently. If we could see them, they might look like glowing invisible threads everywhere, and they'd pierce right through the planet, stretching far into space. But this is only the beginning. Now scientists need to refine their models, make them even more detailed, and compare their predictions to real galaxies. But this dark star discovery in the galaxy's center isn't our only clue. Luckily, the universe has given us a way to look for that fingerprint – gravitational lensing. When light from a faraway galaxy travels toward us, it sometimes passes by another massive galaxy on the way, or other massive objects with crazy gravity. Instead of continuing in a straight stream, light actually gets bent around the massive object because of that gravity. And when it finally reaches us, it creates a distorted and magnified version of the original galaxy. Basically, it's like looking through a piece of curved glass. If dark matter is fuzzy, then it should leave a strange pattern on these distorted images. Things should be a bit wavy and unclear. Scientists needed the perfect object to study this, and they found one. A faraway galaxy whose light was bent by gravity, creating a strange stretched-out image. They used super-powerful radio telescopes, connected them all over the world, and turned them into one giant telescope as big as the Earth itself. With this, they could zoom in so much that they could see details of that galaxy as tiny as a grain of sand on the moon. Then they ran a huge experiment. They created their own fake versions of this picture, simulations with various sizes of fuzzy dark matter particles. And at a certain point, they found the perfect match. This helped us calculate the exact mass of dark matter particles before we even detected them. And the clues are leading us right to our own galaxy. It seems like densest parts of these hairs, the roots, might be super close in the cosmic scale, just tens of thousands of miles from Earth. That's close enough for a space probe to reach. Now that scientists have found this invisible star at the Milky Way center, we just need to study it up close, send a mission to one of these roots, and then we might finally crack the greatest space mystery of all. Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, Experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense. At the same time, a volcanic supereruption is way more likely than an asteroid impact. And right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalus eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sunthunkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions.
NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the Sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the Sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
This signal had been traveling through space for 200 million years, and now, when it finally reached Earth, it brought a fascinating story with itself. It might even help us solve an 18-year-long mystery. We caught this one in 2022. It was such an intense burst of radio waves. Even though it lit up for a fraction of a second, it outshined entire galaxies. At first, the signal hasn't caught attention because we've seen similar things before. It was a fast radio burst, or FRB for short. These guys have been a mystery for years now, all because we have no idea where they come from. Now, FRBs are brief booms of energy coming to us from all over outer space. They're barely catchable, lasting up to 3 seconds. But they're also very hard to miss because their power is absolutely unimaginable. One little burst can release as much energy as the sun does in an entire day. They've been a puzzle for us ever since 2007. We've caught over 1,000 of those signals from literally everywhere, from our own galaxy to places as far as 8 billion light-years away. And none of them revealed where they're coming from or what they mean. At least we know they're not from extraterrestrial creatures. They have to be coming from something that happens nearly constantly, and this recent signal might finally help us learn the truth. It lasted about 2 milliseconds, and it wasn't particularly bright. But when researchers took a closer look, they realized they can actually finally track this one. They got to it immediately. They saw that the burst came from a galaxy about 200 million light-years away. In other words, this is exactly how long these radio waves have been traveling to us. The signal flickered in a weird pattern. This is what we call a scintillation. When light or radio waves travel to us, they can stumble upon unexpected crazy clouds of gas. The particles in light waves start bouncing off this gas, which disturbs the signal a little bit. So when we received it, it was a bit weird and distorted, kind of like me. But this exact cloud was what helped us locate where exactly this signal came from. Turns out, it came from a neutron star. Now these are some fascinating guys. They're the remnants of stars that live fast and burn bright. When a powerful star like this, much larger than our Earth, runs out of fuel, it can no longer support its weight. So it goes away with an insane spectacle called a supernova. During its last moments, its core collapses under its own super-strong gravity, and this creates one of the densest objects in the universe. Again, a lot like me. Hey, what can I say? For curiosity, let's compare it to osmium, the most dense element on our planet. If you had a small cube of osmium, it would weigh around 0.8 pounds. That's already pretty heavy, and it means that 1 cubic foot of osmium would weigh a shocking 1,410 pounds. That's like an average cow. Now, just try to guess how much a small cube of neutron star would weigh. Wrong. It would be a horrifying 7 billion tons per one little cube. Don't even think about holding it in your hand. That thing would warp the fabric of reality around it. It's kind of like trying to imagine Mount Everest being squeezed into a tiny ball. Hard to even imagine. So, even though they're so heavy, these stars are surprisingly small, only about 6 miles in radius. That's like a city size, and it would still weigh more than our Sun. But if that's not enough horror for you, the neutron star we're talking about wasn't your regular one. It was a magnetar. Now, magnetar is a rare type of neutron star. When a neutron star is born, there's only a 10% chance that it will become one of those guys. It can happen if, while the star is collapsing, its magnetic field grows wildly stronger. The spin is rapid, the insides are going wild, and boom! We've got a magnetic field 1 trillion times stronger than Earth's. More than that, these are among the most extreme magnetic fields in the entire universe. They can literally rip atoms apart. Which is exactly what they do. They just rip everything apart. So they end up being surrounded by a super hot, electrically charged soup of particles called plasma. The magnetic field is going wacky, twisting, and bending the plasma as it sees fit. And this all just ends up as an ultra-hot party. Everyone is constantly colliding, scattering, and being absorbed. Not the best place for a hangout. Now, back to our main character. The magnetar in our story also had a plasma soup and a terrifying invisible field surrounding it. And this is exactly where that mysterious signal came from. A signal was born somewhere in that place, at a distance of 6,200 miles away from the magnetar. Sounds like a lot, but that's a distance shorter than a flight from New York to Singapore. But this is very weird, because how can a radio burst even escape a place like that? Now, usually they'd end up being blocked or absorbed. Most often, radio waves end up hanging out there like in a cage. This one, however, managed to break free somehow, which means that something happened that punched through the plasma. Energy somehow goes goofy, twists and reshapes itself in such ways that it starts releasing radio waves. Now, in any case, this means that FRBs most likely come from neutron stars and various types, like magnetars or pulsars. Recently, astronomers made a new amazing telescope called CHIME, the Canadian Hydrogen Intensity Mapping Experiment, a mouthful. This one detects FRBs literally every day. FRBs are full of surprises in general. In the same year, we discovered an FRB with periodic peaks lasting over 3 seconds, much longer than typical bursts. This one could also come from a neutron star. But if it was just neutron stars, we wouldn't probably receive them all that often. It looks like these signals are very diverse and might actually be born from all sorts of places, like near black holes. So there are some other theories about their origin. For example, they could come from 2 stars smashing into each other. What could be more epic than that? A collision of 2 stars would release unimaginable energy, and they destroy each other completely. Uh-oh. Some astronomers think they could explain FRBs, but of course, that's not something that happens often at all. Also, FRBs sometimes repeat. Most of them flash once and disappear, but sometimes they almost flicker like the one we discussed. Some of them even follow very precise patterns. For example, one well-known repeater follows a 16-day cycle. It goes crazy for about 4 days and then goes quiet for 12 days before starting again. This one is hard to explain even with neutron stars. There has to be some unique astrophysical mechanism at play. Maybe something that orbits something else. But anyway, a star's collision would only explain signals that flash once and never again. Another possibility is the blitzar. It's a goofy name for a very dramatic idea: a neutron star turning into a black hole. Once again, an event like that unleashes a huge burst of radio waves. But, again, an occasion like that would be incredibly rare, and the signals aren't supposed to repeat. Black holes themselves are a pretty good option, though. They're central to many FRB theories. Could these bursts come from a neutron star falling into a black hole? Or from a collapsing black hole itself? Maybe even dark matter interacting with a black hole? Hey, who knows? Let's just throw all the ideas in there. Of course, the thing that everyone's most excited about is extraterrestrial civilization. Maybe not all of these bursts, but at least some of them could be signals from our intelligent neighbors. But like we said, that's very unlikely, considering that the signals come from all over the sky and many different distances. Also, almost all of them are the same, and that would be super hard and weird from an intelligent civilization to try and reproduce. Though who knows what else we might discover in the future. Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core, but the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve: what caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense, Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the Moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the Moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the Moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the Moon, too? Now, think about the vastness of the universe. Our galaxy contains between 100 and 400 billion stars. Many of them can potentially host planets. Many of those planets might have water in them and be capable of supporting life. And this is just the Milky Way alone. What's the likelihood of other intelligent civilizations existing out there? Well, there's a famous formula called the Drake equation. It's a mathematical tool to guess how many civilizations from outer space might be able to talk to us in our Milky Way galaxy. It was made by a scientist named Frank Drake in 1961. Here are the variables in it. N is the number of civilizations we could potentially talk to in our galaxy. R star is how fast new stars are born in our galaxy. F sub p is the fraction of stars with planets around them. N sub e is the average number of planets around each star that could support life. F sub L is the fraction of those planets where life might actually start. F sub I is the fraction of planets with life that could become smart civilizations. F sub c is the fraction of smart civilizations that send signals into space. And L is how long those civilizations keep sending signals. Of course, we won't get an exact number like this. It's more like an educated guess, and we don't have any answer to that. But based on at least some information we know, there might be around 100 million worlds where life should have evolved. But if that's the case, then why haven't we met or heard from anyone? This is called the Fermi paradox. It's named after the famous physicist Enrico Fermi. He asked a simple but very important question: where is everybody? Our universe should be filled with chatty extraterrestrial beings, advanced civilizations, and spaceships zipping around. Yet, when we look up at the night sky or listen with our radio telescopes and antennas, it's eerily quiet. All we get is the so-called Great Silence of the universe. Scientists from Oxford University's Future of Humanity Institute are trying to answer this question. And they're not the only ones. A group called METI, for Messaging Extraterrestrial Intelligence, organized a workshop in Paris in 2019 to explore this mystery. The workshop brought together experts from various fields, like astrophysics, biology, psychology, and so on. One of the ideas discussed is called the zoo hypothesis. It suggests that perhaps other civilizations do exist, but they're simply not broadcasting their presence. Maybe they know that making direct contact with us could be risky for both sides. So they're intentionally avoiding us, because they're watching us like observing a zoo. They could be using advanced technology we can't detect. There are also some optimistic explanations, like time delays. Space, as you know, is unimaginably big. The time it takes for signals or information to travel across the universe is enormous. It's possible that other civilizations exist, but their signals haven't reached us yet, or ours haven't reached them. But some explanations aren't very optimistic. Like, some scientists think Earth might really be unique. Maybe the conditions that led to life and intelligent beings are so incredibly rare that there are no other planets like ours. Scientists point out that there are many planets similar to Earth, and some are much older. This means there should be plenty of planets where life could evolve. Recent research also suggests that life might be way more resilient than we thought. And, well, while it increases the amount of life existing out there, it also increases the chances that intelligent life doesn't last very long. It might destroy itself before it can spread to other parts of the universe. This is a concerning idea for the future of humanity. The researchers also considered that many planets might be at a similar stage in their development. That's why it's hard for them to explore the universe at the same time. But even they agreed that this explanation is way too far-fetched. And finally, one of the big potential explanations is called the Great Filter. This idea was suggested in the 1990s by Robin Hanson. It says that for life to develop and become advanced like us, it has to overcome some really tough challenges. First of all, the planet itself should have a good stable star and good enough conditions on it. Then life has to start on that planet. These life forms need to be able to reproduce using things like DNA. Simple cells must evolve into more complex cells. More complex organisms with multiple cells must develop. And eventually, these organisms must figure out how to reproduce, which increases genetic diversity. And finally, these organisms must be smart enough to use tools, create, and explore things. Finally, they should colonize other planets and star systems without destroying themselves. And maybe one of these stages is so incredibly hard that most civilizations don't make it past that point. This challenge could be something like developing intelligence in the first place, or it might be the struggle to avoid self-destruction. So, perhaps life isn't rare at all, but most of it doesn't go beyond simple tiny organisms like bacteria. Even if the universe is full of bacteria, they don't become advanced enough to build spaceships. The Great Filter might also be something from outside, like a huge asteroid crashing into a planet, a dangerous burst of gamma rays, or a massive star going supernova. These events could destroy life on any planet, no matter how advanced they are. So, if we've already passed this challenge, it means we could be the only ones in the universe and we can explore it. But if we suddenly hear from a super advanced civilization, it could mean the hard part of the challenge is still ahead of us. Now, the Fermi paradox focuses on intelligent civilizations. It just implies that there should be civilizations more advanced than us, or at least as intelligent as us. But if you think about it, why should extraterrestrial life be similar to ours at all? It might be completely different for many important reasons. Life elsewhere might have developed under completely unique conditions. This could lead to forms of intelligence and consciousness very unlike our own. For example, it could have evolved into highly advanced forms that aren't based on biology as we know it. These beings could exist as energy-based entities, silicon-based life forms, or even as a hive mind. And because they have evolved completely differently, they may be capable of things that we aren't capable of. For example, we can't see the entire light spectrum. Our eyes also can't perceive cool things like dark matter. But who knows what the vision of extraterrestrial beings may be capable of? Their abilities might even extend beyond our three-dimensional perception. They might be able to perceive and interact with higher dimensions, which is why they could have unique, interesting insights into the nature of our world. Or maybe they've learned to think outside of time, like in the movie Arrival. For us, we still haven't met them, but for extraterrestrial beings themselves, the concept of time doesn't exist at all. They're simultaneously in the past, present, and future. For humans, something like this is hard to even imagine. Plus, even on Earth, we don't fully grasp how consciousness works or why it exists. We're not even sure when exactly we became conscious. So even if we do encounter extraterrestrial life, it will be hard for us to understand them or communicate with them. We think that they might have entirely different language systems, symbols, and so on, but they might not even have any communication systems at all. As you can see, the possibilities are endless. Evolution is a process that can go in many different directions. It's possible that extraterrestrial life developed in ways we can't easily understand or even imagine. These things are intriguing to think about. There are still no easy answers. The Fermi paradox remains one of the most exciting and mystery questions in science. Scientists continue to explore these mysteries through a multidisciplinary approach. They're hoping to find clues that could lead to breakthroughs in our understanding of alien intelligence. And until we find a definitive answer, we can keep sparking our curiosity and imagination.
For centuries, people believed that all swans were white because that was all they had ever seen. They thought it was a universal truth. Then one day, someone discovered a black swan. It was a surprising and unexpected event because it went against what everyone believed. So yeah, the theory is named after this idea of a rare and unpredictable event that goes against our assumptions and expectations. It isn't related to the Darren Aronofsky movie. You know, the one starring Natalie Portman as a committed dancer? Nassim Nicholas Taleb is the person who named this theory. He suggested that these types of super rare and unexpected events are impossible to predict, but they can have a massive impact on individuals, businesses, and societies. The theory was originally used to explain financial markets, but has found its way into various fields. Taleb calls those extremely rare events black swans. Now, these events are so rare that the usual tools of probability and prediction, like the normal distribution, don't really work. They rely on large populations and past data, which we don't have for rare events. So, trying to use statistics based on the past won't help us predict black swans. Let's dive into some examples of past black swan events. The rise of the internet is actually a great example. It's now hard to imagine a time when people couldn't Google their burning questions or watch funny cat videos online. The internet's growth and impact caught many by surprise. It transformed the way we communicate, access information, and even buy fluffy socks without leaving the couch. A digital revolution nobody truly saw coming. Recently, we found an infant black swan on the internet: the emergence of cryptocurrencies. Bitcoin and other cryptocurrencies created new forms of decentralized digital currency and disrupted traditional financial systems. Then we have the invention of smartphones. Picture a world where phones were chunky, had buttons, and only made calls. Suddenly, boom! Smartphones turned everyone into walking wizards with tiny devices in their pockets. From taking selfies to driving with GPS, these pocket-sized marvels changed the game, surprising us all with their incredible capabilities. Here we can also mention the rise of social media. The emergence of platforms like Instagram revolutionized communication, enabling people to connect and share information globally. The creation of the internal combustion engine was a game changer too. Long ago, horses trotted along the streets, leaving a different kind of horsepower behind. But then, ta-da! The internal combustion engine roared to life, propelling cars and transforming transportation forever. Who would have thought that a mechanical contraption could replace our equine friends and pave the way for road trips and drive-thrus? What about black swans related to our bodies, like decoding DNA? Once upon a time, DNA was a mysterious code, like a secret language of life itself. Then, science unraveled its secrets, revealing the blueprint that makes us who we are. This groundbreaking discovery in genetics opened doors to medical advancements and personalized medicine. Imagine you're a scientist working in a lab. One day, you forget to clean up your petri dishes. You know, those plastic or glass things commonly used for growing microorganisms. Then, you leave for a vacation. When you return, you find a happy accident. A mold called penicillin has grown on one of the dishes and exterminated the bacteria around it. That's what happened to Alexander Fleming. This accidental encounter with mold led to the discovery of penicillin. Hello, one of the most important medications in history. At the time, bacterial infections were a major threat to human health. Fleming's chance observation opened the door to a whole new way of fighting infections and revolutionized medicine. Now let's take a peek at Europe in the 14th to 17th centuries. It was like a scene from a historical movie. People are emerging from the Dark Ages, embracing newfound knowledge and experiencing an explosion of creativity. This period is none other than the Renaissance. It's a black swan too, because during that time, there was a tremendous surge in artistic, scientific, and philosophical achievements. Incredible minds like Leonardo da Vinci, Michelangelo, and Galileo were pushing the boundaries of human knowledge. The Renaissance was like a giant wake-up call for Europe, shaking off the cobwebs of the past and embracing a new way of thinking. It was a black swan event because it changed the course of history and ushered in a period of immense progress and innovation. It reminds us that sometimes, out of the blue, a wave of inspiration and brilliance can transform the world. Let's take a step back, or 1,000 steps further, and consider the moon landing. The Apollo 11 moon landing in 1969 was an extraordinary feat of human achievement and a positive black swan event. It showed humanity's potential for exploration and scientific advancement, inspiring generations and pushing the boundaries of what was deemed possible. Not all black swans are good and positive though. When it comes to the stock market, a black swan event is like a super rare market crash that goes way beyond what anyone could expect. We're talking about events that statistically should hardly ever happen. The Great Depression is a classic example of a black swan event. It happened in 1929, but its effects lasted for a long time. The economy was booming with happy days. Then, the stock market crashed and everything went haywire. It was almost impossible to predict, like trying to guess the lottery numbers but on a global scale. The world had never seen such a massive economic meltdown. At its peak, 25% of Americans found themselves without a job. The economy took a nosedive. The US GDP dropped by 30%. Over 9,000 banks waved the white flag and said, "We're out." Oh, and there's something called a gray swan event, too. It's not as rare as a black swan, but it's still an outlier. The good news is that gray swans are a bit more predictable than black swans, so we can better prepare for them and take some measures to protect ourselves. Let's play a little thought game. Imagine we're weighing a bunch of people, and one of them happens to be the heaviest person in the world. Even if that person weighs 2,000 pounds, it doesn't really make a big difference in the overall average weight of everyone we weigh. It's like a drop in the bucket. This shows that extreme outliers like this super heavy person don't have a huge impact on the average. Now let's do a similar experiment, but this time with wealth. We gather a group of people, including one billionaire. What if that billionaire's wealth is 99% of the total group's wealth? Unlike the weight example here, the outlier dominates everything else. This is what Taleb calls extremistan, where a small number of people have a huge portion of wealth, while others have very little. Taleb argues that the modern world operates more like money. It's mostly digital and not constrained by physical or biological limits. While most people don't make a lot of money, a few can make a ton. The same applies to other areas like music, book sales, and more. This winner-take-all system rewards a small number of individuals disproportionately. We tend to believe we understand why these outliers exist. We think it's all about thinking outside the box, starting a revolutionary company, and working tirelessly. But what about those people who did all these things and failed? You don't often hear about them or find shelves full of books about their failures. There's a bias in the stories we hear and the information available to us. In the end, we became more vulnerable to black swans. So, whether it's a mold leading to life-saving antibiotics or an economic crisis, these events of the black swan theory show us that unexpected events can have impacts on our lives. By the way, the odds of being born are 1 in 400 trillion. For all we know and don't know, being born is an unimaginably improbable event that nobody could have truly foreseen. So if you're alive, in a sense, you're a black swan too.
Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really, it suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fault protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments. Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is. An asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So, many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kinda like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time. A bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact. That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet, so it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the Sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards. Strange explosions in vibrant blue colors are popping up around the universe and keeping astronomers intrigued. This rare and incredibly powerful event has a fancy name: Luminous Fast Blue Optical Transient. This phenomenon doesn't behave like anything else we know of, and things got even stranger when the most recent one happened in a spot it shouldn't have. To really understand what happened last year, we need to go back a bit. This type of strange explosion was spotted first in June 2018. The blue blast happened about 200 million light-years from Earth and got the nickname the Cow. No, this happening didn't resemble a cow at all, but it did have an unusual format. Back then, this blast was the most asymmetrical explosion ever seen by astronomers. It burst into space in a flattened pancake-like shape, not in a typical sphere as they would expect. This phenomenon was similar to a supernova, which is the most common type of cosmic explosion that happens when a star exhausts its nuclear fuel and collapses under its own gravity. However, scientists also noted three crucial differences. Number one, this phenomenon is more powerful than a typical supernova. When it happens, the blue burst emits more energy than an entire galaxy of hundreds of billions of stars like the Sun. Number two, it's much faster. The explosion reaches its peak brightness and fades away within a matter of days, while a supernova can take weeks or even months to completely dissipate. And the last difference, these blue bursts can also be much brighter. These mysterious objects are considered the brightest known optical phenomenon in the universe. But unlike a regular supernova, it's believed that there are no radioactive elements to power this brightness. So that means the power must come from somewhere else. The question is, from where? This is just one of the mysteries that the scientists are trying to figure out. There have been some heavy investigations since the event was first observed, and 15 telescopes around the world are constantly looking for it. Since 2018, these extreme explosions have been spotted about once a year. So while they're rare, they're not incredibly uncommon. There are several possible explanations for the existence of these fast optical transients. Perhaps the most acceptable one is that it is a stellar corpse. I mean, what is left behind when a star calls it quits. So we're looking at two prime suspects here. It could be a neutron star or a black hole, producing emissions close to the speed of light. The theory goes like this. There is a massive star much larger than those that produce regular supernovas. Then it starts to collapse. Such an event would certainly be expected to leave a black hole behind. Let's say this massive star isn't ready to leave the universe in a quiet way. Instead, it creates a swirling disk around the black hole composed of gas, dust, and other matter, like it matters. This disk, called the accretion disk, can shoot out streams of material at incredibly high speeds, almost like powerful cosmic jets. and that could be exactly what we see as those sudden bursts of light. Again, it's just a theory. What exactly sets off these blasts remains a mystery, and much more observation and analysis are needed. Experts believe that explaining such an oddity is a scientific goldmine. After all, we're talking about a stellar corpse that isn't just sitting there, it's actually quite active. Now, since this event was first spotted, all similar occurrences that our telescopes have captured happened in the same place. I mean, the explosions always occurred in the spiral arms of different galaxies. But last year, things changed. The Hubble Space Telescope left scientists speechless in April 2023 when its images caught this same type of weird explosion happening for the first time in the middle of nowhere. Well, it didn't happen inside a galaxy as it was supposed to. It happened in the space between two of them. More precisely, about 50,000 light-years from a large spiral galaxy and about 15,000 light-years from a small one. This event is known today as the Finch. Oh great. So when we finally get closer to finding some answers, the unusual location of the Finch phenomenon came to mess it up again. So maybe there is another explanation for it. Speculation began soon after the discovery. One idea is that it could have been a collision between two neutron stars traveling far outside their host galaxies. These two could have been spiraling toward each other for billions of years, and when they collided, they produced a flare over 100 times brighter than a normal supernova. For this hypothesis to be correct, one of these neutron stars would have to be highly magnetized, amplifying the explosion. Another possibility is that the explosion was a star being torn apart by a black hole with a mass between 100 and 1,000 times that of the Sun. Although we still have lots of questions, one thing is for sure. The Finch is a luminous, fast black optical transient. Except for the weird location where it happened, it has all the other characteristics to be classified as one. It's super bright, like me, and super fast, and its origin is super hard to explain. Plus, the data from the Gemini South Telescope, the Chandra X-ray Telescope, and the Very Large Array Radio Telescope have confirmed it. Adding this latest information only makes it harder and harder for researchers to finally find some kind of pattern in this whole event. The Finch isn't the only peculiar event in this category. Let's head back to the year before, to 2022. A blue explosion was spotted in September, and it got the nickname of Tasmanian Devil. Just like the previous ones, this blue burst came up and disappeared very quickly. Then, something mysterious happened. Exactly 100 days later, observers who were still tracking the phenomenon got an early Christmas gift. They observed another flare-up, and it was as bright and fascinating as the original one. Wait, so we're talking about two similar and strange explosions that happened at the same spot and close in time? Well, this was a first. Quickly, 13 telescopes around the globe all had eyes turned toward the Tasmanian Devil event, including one equipped with a high-speed camera. Over the course of 120 days, they managed to capture another 14 irregular light pulses. This was certainly amazing because it proved that instead of showing up once and fading away as expected, the Tasmanian Devil continued to explode with supernova-like energies again and again and again. Can you imagine such power? This scenario still intrigues the scientific community because it pushes the limits of physics, not only because such extreme energy production, but also because of the short duration bursts. By the way, its flares last from 10 minutes to about 4 hours. Believe me, on the scale of the universe, that's considered super quick. This was the only time that an extended season of this event was observed. However, after some thought, the scientific community split their opinions about it. On one hand, the Tasmanian Devil could have been an utterly unique and one-of-a-kind event. On the other hand, maybe it was just the first time that our telescopes caught it from a more face-on angle. To further understand what's happening, scientists still need to observe larger samples of the phenomenon. All hopes are in the upcoming Vera C. Rubin Observatory, which is currently being constructed in Chile. It will have a 27.5-foot wide telescope, coupled with the world's largest digital camera ever fabricated for this purpose. According to NASA, this technology might finally give us some answers about these blue explosions. We can expect some exciting times ahead, as this could be the start of a new chapter in our understanding of stellar evolution.
On November 2nd, 2000, the first crew of astronauts arrived at the International Space Station. Almost 25 years have passed, and the ISS still remains one of the most outstanding projects created by humanity. During all this time, 280 astronauts from 23 countries have visited the station. This place has become a floating laboratory for space research where people from all over the world come together to explore our universe. The station remains a source of inspiration for writers and movie directors. This is not only one of the most important parts of the scientific field of humankind, but also an important attribute of pop culture. The station makes one circle around Earth every 90 minutes, and very soon, one of its next circles will become the last one. NASA is going to destroy the ISS. Space and science fiction fans may feel sad at this moment, but there are good reasons for such a difficult decision. The ISS, like any physical object, is not eternal, especially in the conditions of outer space. Yes, there's no oxygen, atmosphere, oxidation of materials, and air pressure, but the ISS is moving at an altitude of about 260 miles above the Earth's surface at a speed of 17,900 miles per hour, which is almost 20 times faster than the speed of sound. Also, the space around the planet is filled with debris consisting of broken satellites. And don't forget about stardust and tiny pieces of meteorites. What if something crashes into the station and blows it to pieces? Yeah, NASA is tracking the largest pieces of debris, but there are more and more of them every year. Under such conditions, the station can't serve us forever. The parts are wearing out, and the station fasteners are becoming weaker and require frequent repairs. The station was supposed to only last 15 years, but it will eventually last twice as long. In 2030, astronauts will leave the ISS, and then it will be destroyed. But how can this be done, given the size of this object? It weighs 430 tons and is the size of a football field. It is the largest object after the Moon that flies around our planet. People made 42 launches into space to construct this gigantic structure. Given its size and close location to Earth, destroying the station is a big risk. Just imagine it disintegrating into hundreds and thousands of fragments and falling to the surface of our planet. Yes, some of these chunks will burn up in the atmosphere. Others will fall into the water. But some large parts can fall on cities. It will be a devastating meteor shower. This option is too dangerous, but this is exactly what NASA is about to do. The disposal of the station will probably be a more complex operation than its creation. Of course, scientists have considered other options besides the destruction. For example, we could return all the astronauts to Earth and then send the station to a higher orbit so that it would fly there forever. However, such an operation would be too expensive. In addition, changing the orbit might not save the station from collapsing. We definitely don't need a huge piece of metal that could fall apart at any moment over our heads. That's why destroying the station is the only option. To destroy the station, scientists plan to send it to a lower Earth orbit, then carry it through the atmosphere, where some parts of the station will burn, and after that, submerge the station in a remote part of the ocean, where ships don't sail and fish don't swim. By the way, this place is called Point Nemo, and it's located in the South Pacific Ocean. This is the farthest point from land. For many years, people have been dumping space debris and failed satellites there. It's considered one of the most lifeless and loneliest places on Earth. NASA plans to drop the ISS there, but this requires very precise calculations and control. The operation can't be fulfilled without a special space tug. and this unique machine will be invented by Elon Musk's SpaceX company. Musk signed an $845 million contract with NASA. According to it, the station should be safely destroyed by 2031. And that's how this cinematic operation is going to happen. The device that will lower the ISS to Earth will be built according to the design of the SpaceX Dragon ship capsule. Scientists plan to calculate the details of the station's flight trajectory, all angles of incidence, and the speed of movement. No mistake can be made, as any miscalculation will lead to disaster. Our planet is a giant object with a powerful gravitational force that attracts other objects to itself. The ISS uses thrusters to resist this attraction and stay at the same height. So, first of all, the station will need to reduce its resistance. If necessary, it can use the engines to adjust the route. From an altitude of 260 miles, the station will descend into an orbit of 205 miles above Earth. After that, SpaceX will launch its space tug. All this will happen about a year before the scheduled date of destruction. During this time, the astronauts will fold up scientific equipment, say goodbye to the station, and return home. This sad moment will be recorded on camera and posted on the internet. After that, the whole planet will watch the dramatic finale of the ISS. The space tug will dock with the station and transport it to the lowest point of the orbit, approximately 90 miles above the surface. There, the station will experience huge air resistance. It will become increasingly difficult to control the fall. The tug must be equipped with powerful rocket engines to correct the flight. Scientists will control the shuttle, calculating the trajectory of the fall. Then, SpaceX's device will begin to push the station down. The giant space object will pass through the thickest and most dangerous layers of the atmosphere. It will burn down the station, which will be falling apart by that time. This will be a mesmerizing fire show. Some parts will burn up in the air, others will pass through the barrier. At high speed, incandescent parts will collide with the surface of the Pacific Ocean. Millions of people will be watching the last flight of the space legend on the screens of their gadgets and TVs. The water will be getting closer, and boom! Pieces of those stations will crash into the water with a deafening noise. Many smaller fragments will fall nearby. The entire station will cool down quickly and sink to the ocean floor. Mission completed. But the history of the station won't be over. Point Nemo is 2,700 miles away from the nearest land in any direction. But the best way to get to it is from Easter Island, Chile. What if rich people from all over the world flew to Chile to then travel to Point Nemo? Just imagine, covering thousands of miles just to get to the ISS crash site. People will descend in bathyscaphs to the ocean floor and take out the wreckage of the station. Someone might start selling them. Someone will keep them at home as part of a collection. Perhaps NASA will retrieve some modules of the station to put them in a museum. But what will happen once scientists finally get rid of the ISS? The space laboratory is used for research in outer space. After its destruction, research will continue, but on a grander scale. Humanity has to explore Mars, remember? For such an important mission, it's necessary to prepare astronauts in conditions close to those on the Red Planet. The Moon is the perfect place. NASA is conducting the Artemis mission. We'll explore the lunar surface, and we will go on a long journey to Mars from there. At the end of 2022, NASA launched a probe that flew beyond the Moon. The next flight will be launched with people on board. The third flight will be the first human outing on the Moon since 1972. Gradually, step by step, the agency plans to land several astronauts and space station modules on the surface of the Moon. They will build large research bases where they will prepare for the first ever human flight to Mars. By the way, would you agree to go on a dangerous journey to the Red Planet? Write your answers in the comments.
You know what? 8 out of 10 people worldwide can't see the Milky Way anymore. And in just 100 years, it might turn into a forgotten tale from the past. It's not that the galaxy is disappearing, but that the cosmos is fading from view. Back in our grandparents' day, they could look up and see this vibrant tapestry of stars. But nowadays, we're lucky if we can even count them on one hand. This has nothing to do with nature. It's all because of the creeping threat of something called light pollution. Next time you walk around a big city after dark, take a moment to notice the large number of street lights, neon billboards, and office buildings shining all night long. Those endless city lights create an artificial brightness that competes with the natural glow of the stars. This is light pollution, and it's getting worse. Every year, Earth gets 10% brighter. That means if someone is born today in an area where you can typically see around 250 stars, when they reach 18, they'll only be able to see about 100 of them. Unfortunately, that's already a problem in big cities, where looking up at the stars is becoming something that you can only do in planetariums. It's gotten to a point where, during an earthquake that knocked out the power in Los Angeles in the 90s, many residents called emergency centers to report a massive silvery cloud in the night sky. But what they were actually seeing, perhaps for the first time, was the Milky Way. When you look at Earth from space, you can see vast areas of North America, Europe, the Middle East, and Asia all lit up. Singapore, Qatar, and Kuwait are some of the most light-polluted countries. On the flip side, remote places like Siberia, the Sahara, and the Amazon rainforest are in total darkness. Light pollution shows up in many forms. First, there is glare, like when you're driving and those bright lights literally make your eyes hurt, leaving you very uncomfortable. Then there is clutter, like Times Square with its crazy mishmash of different bright lights all over the place. Light trespass is when light sneaks into places it shouldn't, like a streetlight shining right into your bedroom. And finally, there is over-illumination, which is just using way too much artificial light for no good reason, like keeping all the office lights on throughout the night when no one is even there. All these forms of light pollution aren't just stealing the beauty of the night sky, they're also interfering with astronomical studies. When we rely too heavily on artificial lights, it messes up the work of Earth-based telescopes. And when that equipment can't do their job properly, we end up needing even more expensive space telescopes like Hubble and James Webb. And let's face it, that costs us billions. Turning night into day actually affects all of us, not just astronomers. Nighttime light messes with our sleep schedule and our body's internal clock. This clock keeps things like brain activity, hormone levels, and cell functions on track. So when it's disrupted, it can lead to serious issues like depression, insomnia, heart problems, or worse. One key process that gets messed up is the production of melatonin, a hormone that kicks in when it's dark. Too much light at night lowers melatonin levels, leading to stress, anxiety, headaches, and sleep deprivation. Blue light is the main villain here. You might think that turning on night mode and getting that orange glow in your phone screen is enough, but it's not. Blue light is also present in LED bulbs, the kind we use at home and in city lighting, because they're cheap and energy efficient. My point is that blue light is basically everywhere, and it's a real challenge to avoid it completely. This is also a big part of why we're not entirely sure how bad light pollution is nowadays. I mean, some statistics suggest that this issue increased by 49% over 25 years, up to 2017. But the real figure may be even higher. The thing is, blue light has shorter wavelengths, and the satellites we depend on today struggle to detect it accurately, meaning they don't quite capture the full extent of the light pollution caused by LED lights. Animals are lost and confused too. Their sleep patterns are also affected. A study from Germany revealed that blackbirds in urban areas are getting active much earlier than those in natural habitats. They wake up and start singing up to 5 hours sooner than their country cousins. Migration behaviors are messed up, especially for birds like sparrows and thrushes who travel at night. You see, they rely on the moon and stars as their internal GPS. So you can imagine how disoriented they get when they spot something like Las Vegas's massive sphere, lit up by 1.2 million LED bulbs. The intense brightness hides stars and disrupts their navigation across thousands of miles and continents. And it's not just that. Artificial lighting is unfortunately causing more birds to crash into skyscrapers and high-rise buildings. Insects, like mosquitoes, are also affected by light pollution. Yep, they're kind of gross, so it might not bug you if they're attracted to artificial lights and meet their fate. But remember, they're a crucial food source for many animals, like bats or frogs, so disrupting their populations could throw off entire food chains. Nighttime lights are causing problems underwater as well. Marine creatures near brightly lit panels off the Welsh coast are changing their behaviors, and fewer sea squirts and sea bristles are hanging out near those lights. Another example involves sea turtles. They typically lay their eggs on beaches and often return to the same spots for years. But when those beaches are too bright at night, female turtles might become confused and decide not to lay their eggs there. Now, do we really need all this light? It's hard to say. Some people might feel safer at night, while others think the opposite. You see, it's usually the glare that messes up our sight. Here's an example. If there's a super bright lamp blocking our view, say at a gate, we can't see anything but the light. But check this out. If we partially cover the light with our hands, suddenly we can spot an intruder. Wow. What I mean is that more lamps don't always mean more safety. It's all about using them the right way, and doing things like dimming lights can actually enhance security. Plus, it could save you some cash. Speaking of which, light waste has a pretty big impact on the economy. Take a Cobra Head streetlight, for instance. The light projected directly by it is only 30% of the total light it emits. In the US alone, roughly 1/3 of the light at night goes to waste, and that adds up to a staggering annual cost of $2.2 billion. Electric lights aren't all bad, of course. They have done some good stuff for us, like making our days longer so we can get more done and have some fun after work. But we can totally minimize this issue. Turning off all the lights would be awesome, but let's be real, that is very difficult, if not impossible these days. So, what can we do? Get those fancy controls like dimmers, timers, and motion sensors to make sure our lights are super efficient. Go for warmer colored lamps instead of those harsh blue ones. Oh, and consider using fully shielded light fixtures, like those cool vintage table lamps. They direct the light down where you need it, so you don't get that annoying glare or light scattering everywhere. Plus, when you cut down on wasted light, you're not just helping out the planet, you're also saving some cash on your electric bill. Talk about a win-win!